simultaneous equations by another method. And the name for this is by elimination. So the previous one was by substitution. And we're now going to do the same idea, but we're going to do it by what's called elimination. And sometimes this is just a lot easier than doing it by substitution. So for example, if we had something like 3x plus 4y equals 12 and 2x minus 4y equals 7. That'll do for a set of simultaneous equations. Again, we're probably going to get ugly numbers, but it doesn't matter. Okay, so if we look at that, then the way that we're going to do it the previous way, we'd have had to pick one equation, rearrange it to make one thing, either the x or the y of the subject, substitute into the other equation, and it's obviously a reasonably involved process. It's not, not horrific, and you could do it, but there's a much better way of doing it than that. And basically what we're going to do is, we're just going to, in this case, add the two equations together. Okay? This doesn't change the relationships. The things are still equal. It's kind of like if I have a seesaw and I say that's balanced, those things are equal. And if I have black triangles, and I take off the green squares, it's still equal, it's going to be balanced. If I add the two things together, so on this end I've got a green square and a black triangle, and this side I've got a green square and a black triangle, it's still going to be balanced. Yep, so that's exactly what I'm doing here. I'm just saying that's a green square and that's a green square, that's a black triangle and that's a black triangle. Independently they're balanced, but if I add them together, still balanced. Okay, so I'm just going to add the two equations together. So if I add the two equations together, this side's nice and easy, 12 plus 7 I can do, that's easy, 19. Yep, and if I add the other side together, what have I got? Well, 3x and 2x is 5x, and 4y and negative 4y, oh, that's 0. That makes it easy. So the answer to the equation is just 5x equals 19. So x equals 19 over 5. Simple way, very easy. Much easier than having to rearrange to make y the substitute, bung it into the other one and carry on. So that's really very easy way to get x by itself. What do I do when I've got x once I've got x, what do I have to do to finish the question? An equation, okay, so use an equation to find y. Which one do you want to use, Karen? Use the top one? Okay, that's fine by me. So 3 lots of x plus 4 lots of y equals 12. Beat that up a bit to get y by itself. So y equals 1/4 of 12 minus 3 lots of 19 over 5. Oh yeah, good one. I've done a good one here, haven't I? 57 over 5, 12, 5 is 60, 60 minus 57 is 3/5. How about 3 over 20? Someone want to find out whether that's, use a calculator and see if that's right? Yep, happy with that? Going well. Okay, so we've got an answer. So we think the solution is x 19 over 5 and y is 3 over 20. Simple. And then we can check in the other equation. Okay, so if we check it into the other equation, which is the bottom one, isn't it? So we're going to check it into 2x minus 4y equals 7. 2 lots of x, which is 19 over 5, minus 4 lots of y, which is 3 over 20. So what's that? 2 lots of it's 38 over 5, minus 3 over 5 equals 35 over 5, which is 7. And we're done. So it does work. Okay, so the check works, and we know that it works. So we have those as our solution. Just because I'm just pulling equations out of my head and chucking them on the board, the numbers aren't coming out particularly nice, but that's the reality of life. Very rarely in engineering do things happen to just work out to be whole numbers. If you're building something, you're trying to work out where the points of intersection are, it's unlikely to be exactly 3 meters and 7 meters. It just doesn't happen that way very often. So get used to seeing weird fractions and things. It's part of life. Okay, so that's the elimination process. Where instead of trying to rearrange and substitute, you can just add the things together and it comes out a lot easier. Yeah, has anybody not spotted why did that work out so easily in that occasion? The y's just happened to cancel each other, didn't they? So say we have one which is like 3x plus 4y equals 12, and 3x minus 7y equals 15. The x's are the same? Yeah, they are. So if I add them, the x's aren't going to go away, are they? So how can I make the x's go away in that case? Could multiply by -1, or we could just do a minus rather than an add. There's no rule that says it has to be an add. We can subtract. Okay, so we could do a subtraction. So 3x, take away 3x, nothing. 4y, take away -7y is 11y. 12, take away 15 is -3. So y is -3/11. Yep. And once you've got that, then you just go through your process, which I'll do for you. So you've got lots of examples of seeing it being done. Yeah. So it doesn't have to be add, you can subtract. Okay, so once I've got the y, what's the next thing I want to do in this question? Top equation. Jaden's opting for the top equation, so I'm going to pop in the top equation to find x. Okay, so use an equation to find x. So we use the top equation, so 3 lots of x plus 4 lots of -3/11 has to equal 12. So x has to equal 1/3 of 12 plus, plus will be what, 12/11, which is, what's that going to be? 132, 144. $144 over 33, which is 33 and 15. Is that right? 33 and 15, maybe 38 elevenths. No, that's wrong. Ditch, 48. Yep, no, yes. Happy with that. Done it two ways. It works out both ways. Yep, again, calculator is your friend. That's right. Yep, cool. We're right with 48 elevenths. Thank goodness for that. So the solution is, Shane, what am I going to write for the solution here? Which one goes here? Well done. And here. Well done. Yep, always X first, eh? Yep, good stuff. And that's one, Michael, that if you'd done it as a decimal, it would have come out this number here. You'd have got negative, whatever it is. It's not the same as exact number because you have to chop it at some point. And then when you put it into this one, you'd have got something slightly off as well. Yeah. So keeping it as a fraction is definitely helpful if you can. And what do you want to do with that solution? Check it in the other equation. Check in the other equation. So the other equation, we used the top one, didn't we? So this is the other one is the bottom one. So 3x minus 7y equals 15. 3 lots of x, which is 48 elevenths, minus 7 lots of y, which we think is negative 3 elevenths. What's that? 3 times 48 is 120 and 144 elevenths plus 21 elevenths, which is 165 elevenths, which is 15. Just 2. Awesome. Yep, so it works. We can check it back and we know we've got the answer right. What was that? It better work for the top one. See, we use the top one to get it. It has to work for the top one because that's the one we use to get it with. So it's not surprising it works for the top one. Yep, so that's what I mean. Serious question, okay, that's what I mean by other. Yep, so when we used an equation, I was using that equation. So when I say other equation, it's got to be that one. Yeah, because there's no point checking it into this one when you've used this one to get it. You know it's going to work there. It has to work. Cool. Yep, so you can, if you've got things that have got a plus and a minus, you can add them and it disappears. If you've got two things that are exactly the same, you can subtract it and it disappears. Which leaves us with the last type. Say we had one that looked like this. Just give me one. Just add a little bit to it. Just add one level of complexity, just the same thing. Say we had something that looked like that. There's two things here that are a bit problematic. What's the first one? You want to move the 12 over. Yeah, so the problem here is that the two equations don't look the same. So when you're trying to balance them, like I had that seesaw idea before, they don't look the same. So let's just move the 12 over. So let's change the equations to be 3x plus 4y equals 17 and 2x minus 3x equals 12. Okay, so now they at least look the same. Yep. So just rearrange it to make them look the same. Yep. So hopefully that overcomes that problem, so they look the same. That's true. The y would be a problem in that I'm an idiot, and that should have been a y, and that should have been a y. So now they do actually look the same. Otherwise it was too easy, wasn't it? You just worked out that x equals whatever it was and stuck it in there and away you go. So I have to bring some candy for anyone that spots a mistake on the board. That was just me being an idiot. Okay, so now they do actually look a bit more the same. They've got an x and a y in each bit of them. Okay, so when you stare at those, what's the drama now? There's no matches, is there? So if I add them, nothing's going to go away, and if I subtract them, nothing's going to go away. There's no match like there was in the previous one. So what do you want to do to get a match? We need a match. There has to be a match, otherwise it doesn't work. How can you get about getting a match? Yeah, no. The problem with that is that if you make one of the letters 0, that's assuming that 0 is an answer. So it would only work if it happened to be that the point was at 0. So very unlikely that it's going to be true. Yep. So. Okay. Now this is exactly what you do. Okay. So in terms of what I had before, I had my seesaw, and I had green squares and black triangles. So I had a green square and a black triangle. Yeah, and I said balanced. Yep, I can add them because it's still balanced. What say I now do this? Still balanced? Yep. So as long as I use the same number on both sides, it's still balanced. So I could make my green square equation, I could do 4 times that equation if I wanted to. So I could take this whole equation and times it by 4, and it would still be balanced. And I could take this whole equation and multiply it by 3, and it would still be balanced. Okay. No, you can do that. You can do whatever you like. You can time this by anything you like. And the trick is to pick something which is helpful, and that would work as well. That's the other way of doing it. Okay, so if we do that, if we do these multiplications, then we're going to multiply this whole thing by 3. So we're going to end up, if we multiply that whole thing by 3, we get 9x plus 12y equals 51. And multiply this whole thing by 4, we get 8x minus, it's a y, minus 12y equals 48. Now do you see why Michael picked 3 and 4? Because they balance. Those guys match now, don't they? Now I can just go through my process. What am I going to do, Kieran? Add or subtract? Add them. Okay, so if we add them, then we get 9 and 8 is 17x. Oh, the y's go away. Add these guys together, 99. So x equals 99 over 17. Exactly? 5.82. Quite a long number, isn't it? Yeah, so you got to choose somewhere to chop it off if you're going to do it as a decimal. which means that when you substitute it back in, the other one number will be only accurate to however many you've chopped it. So fractions will give you the exact number. So I'm going to leave it as a fraction. If the question says give your answer to 2 or 3 decimal places, then for the first one you want to work to at least an extra decimal place or 2, and then when you substitute it back in, you get the second one right to the required number of decimal places. Questions about that? How's that look? Okay, so there's a wee bit of a jiggle. To make them so they eliminate nicely, you've got to get these guys to match. Lovely if you get 1 plus and 1 minus, because then you can add. Jaden's way, he was going to multiply this one by 2 and this one by 3, which would have given you 6 and 6, and then you could have subtracted. And it would have worked out fine as well. Yeah. So either of those approaches is fine. Okay, once we've got one letter, what do we do next? An equation. Use an equation to find, in this case, y, because we've already got x. Okay, so whichever equation we want to use, the bottom one, sure, I don't mind. So 8 lots of x we know is 99 over 17 equals nothing, minus 12 lots of y has to equal 48. So y has to equal 8 lots of 99 over 17 minus 48, 1/12 of all that. Oh, yep. Sure, I'm more than happy to do that. I was not looking forward to having to do 8 times 99 in my head. Okay, so yep, we're going for the sensible approach now. We're going back to one of the original equations. So let's go with the top one. So 3 lots of 99 over 17 plus 4y equals 17. So y equals 1/4 of 17 minus 3 lots of 99 over 17, which is 297 over 17, which I'm going to squeak and ask for a calculator. What's 17 squared? 389 minus 92. What's 92? 23 over 17? Who's got a fraction? Negative 2 over 17. Oh, 289. Yep, buying that. Is that by 100? Embarrassment. Okay, so y is negative 2 over 17. Yep, and then what do we do? You got negative 8 over 17. Did you get the quarter in there? Negative 2. So the solution is whatever x was 99 over 17, and y is negative 2 over 17. And then we check into the other equation. Check in the other equation. So the other equation is this one here. 2x minus 3y minus 12 should equal 0. 2 lots of x minus 3 lots of y minus 12 should equal 0. So what's that, 198 over 17 plus 6 over 17 minus 12. What's 12 is lots of 17? That's 170 and 34, 204 maybe? 204. 204 minus 204 equals 0. Okay, so the processes are the same every time. Like I said, the numbers here, because I've just pulled ones out of my head and put them on the board, it meant that we've got ugly fractions all over the place. But again, you've got a fraction button on your calculator, or you can, you've got to get used to working with them, so here's a good place. Processes, pretty standard. Question, Shane. Yep. So this is a different question. Yep, so if I rub this out, yep, okay, so this one here we can get rid of. So the question is, can you use the elimination method for, what was the example? Yep. Okay, so elimination method would dictate that, do you want to add or subtract? Yeah, I'd subtract. Because if you subtract y minus y is nothing. 5x take away 3x is 2x. 2 take away negative 4 is 6. Yep. So x has to equal negative 6 divided by 2. So x is negative 3. Yep. And once you know x is equal to negative 3, negative 3 back into there is negative 15 plus 2 is negative 13. And does that work for this one? If x is negative 3, you get negative 3 is negative 9, take away 4 is negative 13. Works for both of them. Yeah. So yes, you can use the elimination method. So you can use the elimination method or the substitution method for any question. Okay? It's just sometimes one's a lot easier than the other one.